Today's lesson is going to cover a couple of different concepts, medians and altitudes. And then on the back, we're also going to recover the material about how to find the area of a triangle. So let's first talk about a median. By definition, a median is a line segment, and it's a line segment that connects the vertex of a triangle, so one of the points, to the opposite side's midpoint. So in any triangle, there is the possibility of having three medians. So those medians are drawn in the triangle at the right already, triangle ABC. One of them goes from vertex B, follows down to the midpoint of the opposite side, which is point F. So BF would be called a median of the triangle. There is another one that starts at point A and goes to the other opposite side to point E. E is a midpoint of the opposite side, so AE would be called a median, and the same thing from C up to D. From C to D, we go from vertex to the midpoint of the opposite side, so C to D is called a median. The three medians in a triangle are always going to meet at a point. That point P in this triangle is called the centroid of the triangle. That's a vocabulary term that you're going to need to know. So that point where the medians intersect is called the centroid. Now, why that's important? There's a relationship between the portions of each one of these line segments that I highlighted. So let's take the blue segment, for example. The entire segment length, if I told you it was a numerical value like, say, 21, each of the pieces of the segment are broken into portions of that 21. The top portion is 2/3 of the entire length, and the bottom portion is 1/3 of the entire length. So if I wanted to know what BP was, I would take 2/3 of the entire length, so 2/3 times 21, and that would tell me that BP was 14. If I wanted to know the bottom portion of the segment, from P to F, that portion is 1/3 of the entire length. So I would take 1/3 times 21, and I would get a length of 7. So you've got that relationship, that the larger piece of the median is 2/3 of the whole length, and you have the relationship that the smaller portion of the median is 1/3 of the entire length. The other relationship, if you look at the two values we just found, the small part of the median is half of the large portion, and the same way the other way around, the large portion is twice of the small portion. So if I gave you certain pieces, you would be able to figure out the entire thing. For example, let's take one of the other medians. Say that I tell you from P to E is a value of 5. Well, I know then that the larger piece of the median, the one I'm highlighting in blue right now, that's going to be double of the smaller piece. So if the purple piece, the small piece, is 5, that means that the big piece would be 10, and then the entire median we would know is 15. We can also look at it another way. Say that I tell you that on this median, that piece, I tell you, is 12. So P to C is the larger portion of the median. So if I wanted to find the smaller piece that I just highlighted in blue, it's half of that large piece. So if the purple piece is 12, that means the blue piece would be 6. And then we would know that the entire median length was 18. So there are a lot of different relationships that are happening with your medians. So we want to make note of all of those relationships so that no matter what the situation is, we know how we can figure out those numerical values, or how we can write an equation to solve an algebra equation with a problem like this, like we will on the back. So let's move down, and we're going to look at a picture here where we're just going to do this numerically. So some things to notice. AD is 8. Well, they marked that for you. They said AG is 10. They marked that for you. And then they also tell you that CD is 18. Well, CD is this entire length here. That's 18. That's the whole length, not just a piece of it, it's the whole thing. So I'm going to mark that accordingly so that we can keep track that that's the whole thing. All right, so if I want to figure out the pieces, what the easiest thing may be to do is to figure out the individual chunks so that then all I have to do is look to see what is the problem asking me for. So for example, this purple piece here is 10. That's the large chunk of the median. So if I want this upper piece, that's the smaller part, we said above that it would be exactly half of that. So from G to E is going to be a value of 5. If we want the different pieces of this median, I know the whole thing is 18. We said above that the smaller piece down here is 1/3 of the whole length. And we said that the bigger piece down here is 2/3 of the entire length. Therefore, I can figure out those individual chunks as 6 and 12. The last one that I'm able to figure out is this piece up here. Notice that the bottom portion is 8. I can say that the top portion is also 8 because the whole definition of a median is that D is the midpoint of that side. Just like E is the midpoint of its side, and F is the midpoint of its side. That's by the definition of a median. So if I start looking at what's the problem asking me for, BD is labeled as 8. AB is the entire side length, 16. EG, we labeled already here, we said it was 5. A to E, we said is the entire median length, this whole length. Well, if the pieces are 10 and 5, the whole thing's 15. C to G, we found right here, we said that chunk was 12. And D to G was this chunk here, we said was 6. So just by figuring out all of the lengths in the picture before I even look at the rest of the problem makes finding the actual lengths asked for in 1 through 6 really easy. It's usually a good choice to work with the picture first and then look and see, well, what lengths did I identify that they're actually asking me for? So as we move down, look at another picture. It says you're told that AB and BC are congruent. So these are these outside sides. So think back to a couple of lessons. What does that mean? It means that this big overall triangle, ABC, is isosceles. That's important. We know that we've got a side length down the center that's perpendicular. Now here's the deal with that purple length. Since I know the big triangle is isosceles, and the purple length is perpendicular, it makes it a perpendicular bisector. So not only is it perpendicular, but it makes it a perpendicular bisector. It also means that this angle up here is bisected. So if the right-hand portion is 39, so is the left-hand portion. So if we look to see what's the problem asking me for, it's asking me for AD and the measure of ABC. Well, AD, we said, has to be the same as DC. Well, if DC is 12, so is AD. The measure of angle ABC is the entire vertex angle here at the top. Well, if each side of it is the same, each piece of it, that means that the entire angle is just that 39 plus 39. So each portion of the angle, which gives me a total of 78 degrees. In number 14, it says that G is the centroid, which means that from B to D is a median, from E to C is a median, and from A to F is a median. It means those are all medians. So it wants you to figure out what's FG and what's BD. So FG is this small chunk right here. That's the small piece of the median, which we said is exactly half of the large part of the median. So FG has to be half of the large chunk. So half of 13 comes out a decimal, which is okay. It's just 6.5. If I want to figure out BD, BD is the entire length of the median. The 10 you're given is the big chunk. This chunk down here has to be half of that, which would be 5. So if I want the entire median length, BD is just those two pieces added together, which gives me a median length of 15. Moving down, this gives you coordinates of triangle ABC, and we're supposed to find the centroid of that triangle. So the first thing we want to do is graph the triangle. So let's do that first. Okay, so, oops, sorry, that's wrong. That's 1, 2, 3, 4, 5, 6, 7, 1, 2. Okay, so we're down here, -7, -4. That is vertex A. -3, 5 is vertex B. And 1, -4 is vertex C. And all I'm going to do is connect the dots. So what we're looking for is the centroid of the triangle. Now, if you look back to your definition from above, the centroid is where all of the medians intersect. So in order to find the centroid, what I need to do is I need to draw the median of each, from each vertex to each side. So there are 3 medians. So I'm going to draw all 3 medians into the triangle and figure out where they intersect. Now remember, a median for a triangle is from vertex to the midpoint of the opposite side. So what I need to do is I need to find the midpoint of side AB. I need to find the midpoint of side AC. Oops. And I need to find the midpoint of BC. Because then I can connect point B to the opposite midpoint, point A to the opposite midpoint, point C to the opposite midpoint. So let's figure out the midpoint of AB. Midpoint formula says add the x's together, divide by 2, add the y's together, divide by 2, and that's going to give you a new coordinate point. So simplifying that, it's going to give me -5 as the x and 1/2 as the y. So I have a midpoint at 1, 2, 3, 4, 5 to the left and up 1/2. So I'm about here, and I can draw a line from C to that point. So there's the median from C to point D, we'll say. Let's find the midpoint of side AC. Add the x's, -7 and 1, divide by 2. Add the y's, -4 and -4, divide by 2. And I get a coordinate point of -3, -4. 1, 2, 3, 1, 2, 3, 4. So I get a point down here. We'll call that point E, and we're going to connect from B to E. The last one then, the midpoint of side BC. BC, I have x's of -3 and 1, divide by 2. Y's of 5 and -4, divide by 2. And I get a new coordinate point of -1, 1/2. So -1 up 1/2. I get a midpoint, and then I'm going to connect the dots. So what you're looking for, and we'll call that point F. In order to find the median of a triangle, you're looking for where do the centroid of a triangle, you're looking for where the 3 medians intersect. And to me, it looks like they intersect at the point 1, 2, 3 to the left and 1 down. So we would say that our centroid is at -3, -1. Okay, so in order to find a centroid of a triangle, you're just looking for where do the 3 medians intersect. Flipping to the back, we've got a triangle where we're told G is the centroid, which means that A to F is a median, B to D is a median, and then C to E is a median. So let's label what we're given. In the picture, we're told from C to G is 3x plus 7. And we're told C to E is 6x. So what we're looking for is, what's the relationship between what we're given? Well, the relationship that we're given is that C to G is 2/3 of the whole length, which is C to E. So we use that relationship and we write an equation. The large chunk of the median is 2/3 of the entire length. So 3x plus 7 equals 2/3 of 6x. We solve the equation. 2/3 of 6x is 4x. And if we subtract 3x, we get 7 equals x. Now, if the problem asked me to figure out what was the length of CG, what was the length of EG, or what was the length of EC, I would have to take that x and plug it in. This particular problem just says find the value of x, so we are done with the problem at that point. Now I'm going to erase that stuff, and we're going to move down to the next problem. And let's label with that information. B to G is this portion here, and that is 5x minus 1. D to G is this bottom portion. That piece is 4x minus 5. So what we need to look at is to figure out what's the relationship between what I'm given. Now I'm given the large chunk of a median and the small chunk of a median. So what I know is the large chunk, BG minus 1, is, 5x minus 1, is double of the small one. So it's 2 times 4x minus 5. So again, the large piece of the median is twice as large as the small piece. So what I did was I wrote an equation that said BG, 5x minus 1, which is equals 2 times as large as the small piece, 2 times 4x minus 5. So what we're going to do is solve the equation. 5x minus 1 equals 8x minus 10. And we just need to do a little rearranging. Subtract 5x, add 10. 9 equals 3x. And if I divide, I get an x value of 3. Again, if the problem wanted you to figure out what certain lengths were on the picture, you'd have to plug the x in. This particular set of problems just said find x. Now I will tell you, you are going to have problems like this on your test. So just like last class, you might want to highlight or star or circle these so that when you go back to study for your test, you make sure that you rework some of these problems as practice. Moving down, we said that we were going to talk about another concept today, not only medians, but we're also going to talk about altitudes. Altitudes are special because they are lines that go from a vertex to the opposite side, just like a median. But unlike a median, they don't go to the midpoint necessarily. They just have to meet at a right angle. So in my picture here, I know this center side is an altitude because it hits at a 90-degree angle. It's perpendicular. I know this length out here is an altitude because it hits the bottom at a 90-degree angle. It's perpendicular. That's what tells me I have an altitude. It hits at a right angle. Now, why is an altitude important? Because anytime we find the area of a triangle, we use the formula 1/2 base times height. Now, the deal with that formula is that h is always an altitude. So if you think about that, an altitude has to hit at a 90-degree angle, which means that the height of the triangle always has to hit at a 90-degree angle. You'll never use a slanted side as the height of a triangle. It has to meet at a right angle. It's called an altitude. So there are 3 circumstances for the area of a triangle. One where the altitude is a side of the triangle. That happens in a right triangle. One where the altitude goes down the middle of the triangle. That happens in an acute triangle. And one case where the height is on the outside of the triangle. That happens in an obtuse triangle. So what we need to make sure we do anytime we use our formula is that we're using the correct numbers. So for the first problem here, notice there are 4 numbers listed on that particular picture. In order to use the area of a triangle formula, 1/2 base times height, I only need 2 of those numbers. So we have to make sure that we select the right numbers to use. The base of the triangle will always be a side length, so in this case 3. The height of the triangle always has to be an altitude. So in other words, has to hit that base at a right angle. So of the 4 measurements up there, 3 and 5 are the only ones that are necessary. 6 and 7 are actually just extra information. So if I go ahead and multiply, I end up with an area of 7.5 square units. Since there are no units in the problem, if you just put 7.5, that would be fine. I usually tend to put u squared, so that if there are units, I remember to include them. That's usually the reason why I do that. In the next problem, again, 4 lengths given. Only 2 of them are necessary, so we have to pick the correct 2. Base and height always have to meet at a right angle. So the ones I'm highlighting here in blue are your base and height. 21 for the base, 8 for the height. And again, the 8 is an altitude. So if we multiply it, 1/2, 21, and 8, we get a value of 84. And again, I'm going to put u squared so that if there were units in the problem, I would remember to include the units. The last one is a right triangle. In order to use the area formula for a triangle, we have to know the base and height, and the base and height have to meet at a 90-degree angle. Therefore, 5 is the height, 13 is not the base. The base is this bottom side that I don't know. So the nice thing about the fact that this is a right triangle is we should be able to figure out what that length is by using something we used last semester called Pythagorean theorem. So I'm going to label that as an x, and we're going to do 5 squared plus x squared equals 13 squared. If you square those out, 25 plus x squared equals 169. If you subtract, x squared equals 144. And then in order to undo the x squared, we would square root, and I get a value of 12. So this length down here is 12, and that's the length that I would use in my formula. 1/2 base times height would give me an area of 30 square units. Things to remember, just like last semester, if you're going to find the area of a triangle, the base and height, the numbers that put in the formula, have to meet at a 90-degree angle. Okay, last 2 problems. First one says, find the base length of a triangle with an area of 52 square centimeters. So the first thing I'm going to do is start with the formula, and I'm going to plug in everything that I'm told. The area of the triangle is 52. I'm told the height is 13. So all I have to do is solve for the variable that's left over. So what we're going to do is multiply the 1/2 and the 13. Those 2 get multiplied together. By multiplying those, we get a value of 6.5. And so what I need to do now in order to solve for b is just simply take the 52, and we are going to divide by 6.5. And 52 divided by 6.5 gives me a base length of 8. So looking at my answers, we get a base length of 8. The last problem, instead of telling you what the base and height are, you're given the actual length or the actual area of the triangle, and then you have stuff labeled with x's. No big deal. Let's just plug everything in and see what it gets us. 36 equals 1/2 times the base 2x times the height x. Now, if you remember from Algebra 1 last year, all we need to do is multiply this stuff on the right side together. 1/2 times 2 is 1, and x times x is x squared. Okay, remember that from Algebra 1. X times x is x squared. So all I have to do then to solve for x is take the square root, and the square root of 36 is just 6. If you have questions about any of the problems, don't understand the explanation, want me to rework a problem during class, want me to re-explain or explain in a different way, make sure you make note of that problem so that when I ask for any questions, you have something specific to ask.